Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एबे मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई आ MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें विजिबिलिटी ऑफ फ्रिंजेस ए विषय रे पढिबा जोटा रिलेटेड टू योर माइकलसन इंटरफेरोमीटर. So it is defined as Vf equal to I max minus I min divided by I max plus I min. I max कहले एठी हमें maximum intensity को बुझिबा और I min माने minimum intensity. Okay, so the difference in the maximum and minimum intensity divided by the summation of the maximum and minimum intensity. Okay, so the sum of the intensities of the two interfering beams is also called the average of the fringe oscillation, whereas ये जो difference रोचे intensity भितरे दुईटा जाको interfering beams रो it is called as the amplitude of fringe oscillation. Okay, so the fringe visibility is also defined as the ratio of the amplitude of fringe oscillation to the average of the fringe oscillation. Okay, से हिसाब रे हम याको mathematical लिखि देला. Now fringe visibility actually यार significance कौन it signifies the contrast of the interference in any system. Okay, केमती तार contrast रहिबो, and this fringe visibility is also known as the Michelson visibility or interference visibility. So here the maximum and the minimum values of the intensity eta हमें पाउचु which is equal to I max equal to I1 plus I2 plus 2 square root of I1 I2 cos phi ଆଉ I minimum equal to I1 plus I2 एटी differential एटी minus पड़िबो minus 2 square root I1 I2 cos phi एटी I1 I2 हैला कोन intensity of the two interfering waves अब phi हेगला एटी phase difference or phase angle between the two waves. Now putting these two values of I max and I min in the definition of fringe visibility आमे यदि put करिबा you will get the answer 2 square root of I1 I2 cos phi divided by I1 plus I2. Okay, and jodi in a special particular case of coherent waves where I1 equal to I2 ame negala ताले the visibility हेजिबो यार value simply equal to cos phi. Okay, because एठी तळे हेजिबो एटा 2i एटा हेजिबो I square रो square root that is I, so 2i by 2i कटिगला so cos phi हैला. Okay, that means the fringe visibility is equal to the cosine of the phase angle between the two interfering waves, okay, which are coherent one obviously. Now the factor here cos phi is known as the degree of partial coherence, and in case of complete coherence we have cos phi equal to 1. That means here the interference fringes will have maximum contrast of unity. Okay, maximum value eta yaro unity rahibo. Now in case of complete incoherence of light contrast is kete 0. That means there are no interference fringes at all. So ame yaku तीनटा special condition lekhi pariba. First hela 0 less than cos phi which is equal to 1 for complete coherence, then 0 less than cos phi less than 1 माने 0 और 1 भितर cos phi रो वैल्यू जदि लाई करूची एटा कहूछु हमें पार्शियल कोहेरेंस आ जदि cos phi हे गला 0 याको हमें कंप्लीट इनकोहेरेंस बोली की कहबा. So here a point to remember is that the fringe visibility has a value between 0 and 1. 0 ru 1 भितर यार वैल्यू टा रहिबो. Okay, now let us consider a case of two interfering waves having two different frequencies with wave number let us say k1 and k2 following two different paths with a common path difference that is delta. Then the interfering waves having two different frequencies cannot display interference pattern for times longer than their periods. Okay, so each frequency will produce its own interference pattern. ताले आमे एठी लिखि परिबा गोटे पई सपोज नॉन प्राइम रे लिखिला I इक्वल टू I1 प्लस I2 प्लस 2 स्क्वायर रूट I1 I2 cos phi आ गोटे पई हमें प्राइम कोऑर्डिनेट्स रे लिखिला I डैश इक्वल टू I1 डैश प्लस I2 डैश प्लस 2 स्क्वायर रूट I1 डैश I2 डैश cos phi डैश. Okay, so it as we discussed, the phase angle phi can be written as k1 delta. Okay, माने wave number और path difference भितरे यदि हमें multiplication करिबा we will get obviously the phase angle. Similarly phi dash इगला k2 delta, which are the corresponding phase differences for the two beams path. Okay, acha, now both light beams having different frequencies will cover the same path and will have the same path difference, that is delta. So let us now write the ratio I1 by I2 which is equal to I1 dash by I2 dash. Suppose यारो value को हमें निकला say small r, ताले एबे ratio को हमें जदि नौचो I1 dash ଆଉ I1 which is equal to I2 dash by I2, एटा dash हबनी एठी. Okay, I2 हबो. Suppose याको हमें निकला small a, then the term r is the beam splitter ratio. ଆଉ जो term टा पाइला हमें small a, it is the intensity ratio. Okay, गोटे हला beam splitter ratio, गोटे हला intensity ratio, and the total intensity I net माने net intensity can be determined using the principle of superposition of waves. That means I net will be how much? I plus I dash. यार value हमें put कर देले एतिकी result check करिवो. Okay, so here the first term in the RHS. Okay, RHS रो प्रथम term टा here it represents the average intensity, that is I average, whereas the second term here in the sum of the two interfering terms which are containing the two cosine functions. Okay, दुईटा जाको cosine function एठी रहउची, right? गोटे cos phi आ गोटे cos phi dash अछि, एटा देखो dash अछि. Okay, so एठी हमें लिखि परिबा I net equal to I average plus then the second term. Okay, now ये जो second term रहउची, it signifies that cos phi plus a cos phi dash will show a fast oscillation at the mean wave number frequency and a slow envelope at the wave number difference frequency. Okay, now moving further, the interference pattern with a source of suppose finite size ro ame gote source nela. Okay, ताले visibility of the interference fringes will not be possible when a source of finite size such as like your suppose gote filament bulb noucho, it is used instead of a monochromatic source of light, ताले एबे कोन हबो interference fringe एबे देखा जिवो नाही visibility तारो. So this filament of the bulb can be regarded as a larger number of point sources which are placed side by side, and these point sources are actually incoherent ones. Okay, so it might happen jodi incoherent sources ହେଇଗଲା ताले तो obviously interference हेबो नै. Interference हेबा पई निहाती भाबरे condition हैला those sources should be coherent. That means they have either same phase or a constant phase difference. So it might happen that the maxima due to one part of the filament falls on the maxima due to the some other part of the source. Okay, as you can see एठी suppose एटा हला solid line रे एटा गोटे part हमें देखुछु. Okay, similarly dashed line एठी आ गोटे part रे देखिला. Okay, तेणु maxima गोटे रो आ गोटे उपरे पड़िबार मध्य chance अछि, as you can see in the figure, so that a uniform intensity appears on the screen. जदि तमे इंटेंसिटी को पाथ डिफरेंस अगेंस्ट रे पकेइबो ए सब इंटेंसिटी माने ओवरलैपिंग हेकी गुटे यूनिफॉर्म इंटेंसिटी रो पैटर्न तैयारी करिवे. ओके, अच्छा, so in this case the change in the path difference, that is delta phi, is very large in comparison to the angular width of the interference fringes, that is lambda by d. एटा होचे angular width. Then the maxima from different parts of the source spread by much more than the fringe spacing, and the interference pattern will be washed out. माने किछि भी interference pattern देखा जिवो नहीं. Suppose for an example the sun, सूर्य जो अछि it subtends an angle of 0.5 degree at a point on the earth. Suppose now when the sunlight falls on two narrow slits which are placed 1 millimeter apart, okay, with the screen placed at a distance 1 meter, then angular fringe width केते हेबो lambda by d. याको एबे आमे जदि बाहर करूछु lambda जगह रे सपोज आमे पुट कला 5 into 10 to the power minus 7 divided by d रो value जेमति आमे नीचु 1 mm, that is 10 to the power minus 3, okay, meter. So याको आमे जदि काढिबा यार value आछी 5 into 10 to the power minus 4 radian, that is 100 seconds. Okay, so since this angular width of the sun is nearly equal to 1800 seconds, which is much greater than the angular width which is coming out to be 100 seconds which are observed on the screen, hence we can say no interference pattern will be visible. एटा जेहेतु बहुत कम रहउची, ओके, सन रो जो width रहउची angular टा 1800 सेकेंड, आमे किंतु पाउछु एठी कोन 100 सेकेंड, तेणु इंटरफेरेंस पैटर्न एठी देखा जिवो नाही. Now moving further, the interference pattern due to the monochromatic source. Okay, so for this purpose we consider two lights, gote hela blue a gote hela orange. Suppose blue light ro ethi wavelength ame कहूछु 4500 angstrom आ orange light ro 6000 angstrom. ताले path difference जदि ame blue light रो नबा for n equal to 2 fringe, एटा हि जिवो केते 9000 angstrom because n into lambda हेबो. ओके, सो एटा हे गला 9000 angstrom. अच्छा, ए 9000 को जदि आमे ए ऑरेंज लाइट रो वेवलेंथ सहित कंपेयर करिबा व्हिच इज 6000, दैट मींस इट विल कम आउट टू बी 1.5 times of the wavelength of orange light. So this will give rise to destructive interference. So as the two different wavelengths are incoherent, so intensity केवल add हबो. Okay, so we will see a combination of intensity rather any interference pattern. Now for the central fringe where n equal to 0, it will be formed at theta equal to 0 for all wavelengths, and as the path difference increases, visibility fringes gudaro komi jibo, it will diminish because the maxima of due to one wavelength may coincide with the minima due to some other wavelengths. So we can obtain large number of interference fringes by making the wavelength spread, that is delta lambda, as small as possible. So condition hela ethi for nth fringe to be visible only if the wavelength range, that is delta lambda by wavelength spread, is such that n equal to lambda by delta lambda or delta lambda equal to lambda by n. Suppose in case of your sodium light जोटा कि प्रैक्टिकल पर्पस रे यूज हुए, से आम देखीचु वेवलेंथ थाए 5890 angstrom, आ गोटे थाए 5896 angstrom. तेणु एठी डेल्टा लैम्बडा केते ही गला जस्ट 6 angstrom, which is very small. ओके, एटा हला लैम्बडा 1, एटा हला लैम्बडा 2, राइट. तेणु करी ए केस रे हमें सहज भाव रे visibility देखि परिबा between the fringes, we can obtain the interference. Okay, hence sodium light is used particularly for this interference pattern. Okay, so this is all about the visibility of fringes.
Thank you.